Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about reactive power control, and in that the topic is shunt compensation by reactor and a capacitor. Let us first discuss about a shunt capacitor. Why the shunt capacitor used in the power system? So shunt capacitor is used to correct the under voltages in the system. So what it does? It increases the receiving end voltage. Now it is used for lagging power factor load, because the capacitor, we know that there are two things, L is there and C is there. L, what it will do? It is related to your lag. C, it is related to your lead. So when we connect a shunt capacitor, then it provides a leading current, and the leading current drawn by the capacitor compensates the reactive part of the current which is drawn by the load, due to which the current in the transmission line reduces and hence reduces the voltage drop in the line. Now basically shunt capacitors are used for the reactive power compensation. Shunt capacitors supply the reactive power at the bus, and it is widely used for a lagging load. So please remember, when we have to use a shunt capacitor, when we have lagging load, lagging power factor load, they will boost the local voltage and are used extensively throughout the system in the wide range of the ratings and the sizes. The main advantage associated with this kind of shunt capacitor connection is that low cost and the flexibility. Now let us consider one diagram. This is what is a system with no shunt capacitor is connected, and whatever load which is connected here, this is what is a load which is connected, it is of having a lagging power factor. So this V1 is the sending end voltage, V2 is the receiving end voltage, PS and QS are active and the reactive power component of the source, P load and Q load are active and the reactive component of the powers of the load. Now here, if you observe, the sending end reactive power is always same as that of the receiving end reactive power, because here we are considering that the delta value is very small and the reactive power which is absorbed by the line is neglected. So from the diagram I can write this PS will be equal to P load and QS will be equal to Q load. Now already in the previous video we discussed about the relationship between the voltage and your QS. V2 will be equal to V1 minus X upon V1 into QS. So as we know, QS will be equal to Q load. So in place of this QS, I am going to put here Q load. So we will get this first expression. So here again, V2 is nothing but receiving end voltage. Please remember, this is a system with no shunt capacitor is connected. Now let us consider a second case where the system is with a shunt capacitor which is connected parallel to the lagging load. Now what happens in that case? The PS will be same as that of your P load, but now this QS will be equal to what? It will be equal to Q load minus Q shunt. So therefore, let us assume now this is your receiving end voltage, but here purposefully I have made a star. This star indicates that whenever the shunt capacitor is connected to the system. Initially in the first equation we took value of receiving end voltage was V2, and here we are going to take a value of receiving end voltage is V2 star. This star indicates whenever shunt capacitor is connected in parallel to the lagging load. Now therefore we have written here V2 star will be equal to V1 minus X upon V1 into QS. So in place of the QS, what we will do? We will put here Q load minus Q shunt. Now what is this V2 star? As I already told you, it is the receiving end voltage after having the shunt compensation. Now as the capacitor operates at a leading power factor, that's why we have taken a negative reactive power. Hence if you see here the power factor, or here if you see whatever value of the Q we have taken related to the capacitor, it is Q shunt, and this is treated as a negative because capacitor operates at a leading power factor. Now what happens from equation number 1 and 2? So if you compare this equation 1 and 2, let us write this equation here. So what you will get? Compare means what we have to do? We have to subtract equation number 1 from 2. So by subtracting, we will get the equation as V2 star minus V2 will be equal to X upon V1 into Q shunt. So to this point, V2 star minus V1, I can write it as delta Vc, that is change in the voltage, which is equal to X upon V1 into Q shunt. So this delta Vc is what? It is change in the receiving end voltage. Now, if you observe from this, V2 star minus V2 equal to X upon V1 Q shunt, what you will observe? You will observe one important thing. This V2 star is greater than V2. What is V2 star? It is receiving end voltage when we have a shunt compensation. What is V2? It is receiving end voltage when we don't have a shunt compensation. So that's why the voltage at the receiving end side is going to be increased after having a shunt compensation. That is by connecting capacitor to the load which is connected in a parallel. Now please consider or remember this important note. The shunt capacitors can only be used for lagging power factor loads where the under voltage problem is observed. Because what we observe here, by connecting this shunt capacitor, your receiving end voltage is going to be increased. So wherever there will be a problem of under voltage, what we have to do? If we have a problem of under voltage and if we have a load that is lagging power factor load, then we have to use shunt capacitor. Now if we use it for a leading power factor, then what it will cause? It will cause a problem of over voltage in the system. So this is what is about a shunt capacitor. Now let's have a discussion about a shunt reactor. What is the use of shunt reactor? It is used to avoid the over voltage problem in the system, and therefore it is used for a leading power factor. Please remember, previously in the shunt capacitor it was used for a lagging power factor, but here shunt reactor is used for a leading power factor load. Now whenever the load is a leading power factor, but obvious whatever current which is drawn by that load is also leading. Now the current drawn by the shunt inductor, or we can say shunt reactor, is lagging in nature, and therefore it compensates whatever leading current which is drawn by the load, and therefore what is observed? Reactive component of the current is reduced here. Now let us consider the diagram. Here I have drawn the same diagram, just the difference is that the load which is connected is of leading power factor. So that's why here we have shown P load minus J into Q load. This is the system with no shunt reactor is connected with the leading load. Now what happens here? If you observe, sending end power, active component power PS, and receiving end active component power P load, it will be exactly equal. But here this QS will be equal to minus Q load. Now as we know the equation for the voltage, so we can write the equation of receiving end voltage also. Now why this negative sign is there? Because the load is assumed to be leading power factor. So I can write the expression for V2. V2 is the thing, but it is receiving end voltage when there is no shunt reactor connected with a leading load. So this is the expression that we already studied in the previous video. V2 equal to V1 minus X upon V1 into QS. So in place of QS, what I can write? As we already discussed, QS will be equal to minus Q load. So therefore here in place of QS, if I put here minus Q load, then we will get this expression, which will be what? This will be V2 equal to V1 plus X upon V1 Q load. Mark this as a expression number 1. Now here what you observe? Here we observe one thing. V2 is greater than V1. Means what? Your receiving end voltage is greater as compared to that of sending end voltage. This is what is shown in the Ferranti effect. Here it is observed that there will be a over voltage for a leading power factor. Now let us consider the system in which the shunt reactor is connected with a leading power factor load. So it is denoted as a Q reactor, which will absorb because it is in a lagging mode. So therefore, how we can write the relationship between active component of the power of load and of a supply? So we can write PS will be equal to P load. What is your QS? How I can write it? Now this QS will be equal to, this is your plus Q reactor, this will be minus Q load. So I can write it as QS will be equal to Q reactor minus Q load. So therefore this is what is V2 star. Now what this star indicates, initially in the shunt capacitor also I discussed this thing. V2 star is nothing but it is receiving end voltage when shunt reactor is connected to the system. So V2 star will be equal to V1 minus X upon V1 into QS. I will put here value of QS as Q reactor minus Q load. So what we will get? We will get equation as V2 star will be equal to V1 minus X upon V1 into Q reactor minus Q load. Now what we will do, I will take this Q load first, means I will take a minus sign common. So we will get this expression. This expression is, take this expression as a equation number 2, and which will be V2 star equal to V1 plus X upon V1 Q load minus Q reactor. Already we discussed what is V2 star. It is receiving end voltage after having shunt compensation. Now from equation 1 and 2, if we subtract equation number 1 from 2, then we will get V2 star minus V2 equal to minus X upon V1 into Q reactor. Now already we discussed what is V2 star. It is receiving end voltage when we have a shunt compensation by the reactor. This is V2 is the receiving end voltage when we don't have a shunt compensation by the reactor. So we can write this as delta VL equal to minus X upon V1 into Q reactor. Now here the term delta VL is nothing but what? It is change in the receiving end voltage. So again I have taken the same expression. Now from this expression I can write this as V2 star. If I shift this term towards this side and this term towards this side, then I will get V2 star plus X upon V1 into Q reactor will be equal to V2. So what is observed here? This V2 is greater than V2 star. The meaning is nothing but the voltage at the receiving end side is lesser after having shunt compensation by connecting reactor to it. Now please take a note. This shunt reactor is also called as a Ferranti effect control device, as it reduces the overvoltage problem from the system. So this is what is the shunt compensation by shunt capacitor and shunt reactor. Thank you for watching this video.